Hi, what I'd like to do today is show you something I was just working on. It's a visualization of the Lagrange Point 2 in the Webb telescope. So let's start it. First I will change the center body from the Sun to the Earth. Okay, and then I'm going to select a few bodies including the Sun and Lagrange Point 2, and I'm going to go down to where I have the spacecraft, and I will select the James Webb Space Telescope. You may have heard of that. It was launched not that long ago. And I will plot it over 53 weeks, which is actually a year because the first week is today. All right, so I will animate it so you can see what it does. So this is something I just implemented in my Python program, so it's kind of into it. Okay, so here it is. So let me kind of tell you what we're looking at here. The Earth is that green dot at the center, and that's the Sun. From the geocentric point of view, this is like the way the ancients thought of the solar system. The Sun went around the Earth, and from the Earth's point of view, it does go around the Earth. But the point of doing that is to show you how this works. Okay, so here's Lagrange Point 2, and Lagrange Point 2 is a point where the Earth's gravity is balanced out by the Sun's gravity. So that's why they put the James Webb Telescope close to it. Okay, so I'm going to unselect the orbit of James Webb just so that it's less confusing. And then I'm going to animate it and show you what it does over a year. So over the year, what you really see here is that you don't see it, but the Sun is actually moving around the Earth, okay, from our point of view. And Lagrange Point 2 is opposite to it. So the Sun is somewhere down here, and Lagrange Point 2 is moving around the Earth in a similar orbit, but opposite. And notice that the Webb telescope is has its own orbit around Lagrange Point 2, but it doesn't follow a normal like circular orbit. It kind of goes back and forth to maintain an orbit that's stable, because what it's doing is balancing out the different gravitational influences of the Earth and the Sun in a stable manner, so that it can stay there with minimal use of energy. So I think that's really interesting. Now you can also look at it from this shows you how it's working. I mean, it's far away from the Sun, so you can't see the details, but as we zoom in, we can see what's going on. Okay, now one other thing I want to show you before we end this is a similar plot but static instead of moving, because I can do other stuff with it. One thing I want to show you is the Earth's Hill sphere. So the point of that is to show you how the orbit of, oops, I need to change the, select the year, plot. So it's a static plot. This is not a animation. So basically you're still seeing the same thing, the sun's orbit and the different objects in the center. But here's what's interesting. So that green sphere is what they call the Hill sphere. Okay, and the Hill sphere is the area of the gravitational influence of the Earth. So the edge of it is where it basically balances out between the sun and the Earth. So, and that's where L2 is located. So as it goes around the Earth over a year, it's basically tracking the edge of the Earth's gravitational influence. So I think that's really interesting. I also want to show you one more thing before we quit, so this video doesn't last too long. Okay, so I'm going to shift the view to the center body being L2. Okay, and we can get rid of the sun as an object, and I'm going to get rid of the Earth as an object and just keep the Webb telescope. Okay. So this shows you the pattern. Actually, I'm going to open up the view a little bit. To have an astronomical unit. An astronomical unit is the distance between the sun and the Earth. So this gives us a little bit better view. So L2 is in the center, and here's James Webb. And over a year, it follows this really beautiful path. And you notice it's not a circle. It's a kind of saddle-looking path that basically is maintaining stability between the different gravitational influences of the sun and the Earth around this point. Now this is not an object, this is a point in space where the gravitational influences are balanced out. Okay, and then finally I want to animate it, so let's animate it. I know this video is going on, but I wanted to show you all these things. And again, if you are interested in running this program, it's in my GitHub repository. Okay, so here's the James Webb Telescope. I'm going to play the animation over a year. See how it's making that pattern? Let's do it again. And we can actually shift the view to be Earth-centered and look at the same thing. And this is also on my web page with some explanations and links to different visualizations. Okay, so here's the Earth. There's L2. There's the telescope. And see, as L2 moves around the Earth over the year, so does the telescope. It goes back and forth. Okay, well, I think that's it. Thank you for watching.